Walk through the basics for graphing a parabola, which is the graph of a quadratic equation. Some traits to look at: roots, zeros, x-intercepts, all of these are interchangeable, and you find these by either factoring or the quadratic formula. An old skill. The discriminant, it's the piece of the quadratic formula that sits underneath the radical, so it's this little piece right here. And it tells you if it's positive, you have 2 roots or 2 x-intercepts. If it's negative, you have no x-intercepts. And if it's 0, you have 1 x-intercept. And when the discriminant is 0, that's your pattern. That's the perfect square trinomial pattern. Something that looks like maybe x plus 6 squared equaling 0. The binomial times itself, which creates that little trinomial pattern. The direction of opening is determined by the lead coefficient, so it's determined by A. When A is positive, do this. If A is positive, the direction of opening is up, concave up. If A is positive, it opens up. If A is negative, then it turns down. It's concave down. Concave up, concave down. And then the A comes from just the standard form of the quadratic. There's your basic standard form. So the ABC in all the formulas is derived from that basic standard form of the equation. Let's look at the vertex. The vertex is also considered the turning point. So the vertex is the turning point. So points occur in a parabola in pairs. So I'll draw a little XY grid. Here's X, here's Y. If I have a graph, let's say the vertex is here. Here would be the roots or the x-intercepts. And then points occur in pairs along the curve, crossing the y-axis. The line that divides the curve in half is called the axis of symmetry. I'll just use the initials AOS. The vertex sits at either the top or the bottom, depending upon direction of opening. So the vertex will be the only point on the curve that does not have a symmetric partner. All of the other points occur with symmetric partners. The vertex is the only point without a symmetric partner. The vertex is found by using a formula. So the vertex is an ordered pair. You need both an x and a y coordinate. To find the x coordinate, you use the formula negative b over 2a. Once again, the a and the b coming from the particular quadratic that you're graphing. To find the y partner, I'll use function notation, f of negative b over 2a. And that's just a fancy way of telling you that you're going to take the value of x that you just found and you're going to plug that value into the equation that you're working with. So plug that into the equation. And then what comes out serves as the y-coordinate partner so that you can actually plot the point with both an x-coordinate and a y-coordinate. So the vertex is an ordered pair, and you find the x-coordinate by using the formula, starting with x, negative b over 2a, and then you simply take that value and you plug it back into your equation, and that's what the function notation is telling you to do. Now let's talk about maximum and minimum points. So if the curve opens up, the vertex would be sitting right here at the bottom. So when the curve opens up, meaning that A is positive, so the direction of opening is concave up, the vertex is at the very bottom, so the vertex is a minimum point. It serves as a minimum point on the curve. I'm going to clear the board a little bit. When the shape curves down, the vertex would be sitting at the very top. The vertex serves as a maximum point. And the graph turns down when the lead coefficient, the A, is negative. concave down or concave up. So it's common sense, a little bit of visual formula, a little bit of common sense. And then finally, let's talk about domain and range. The domain for all of the parabolas that we will analyze in Algebra 1, the domain would be all real numbers for all of them, all reals. And then let's do a little example for the range. So I'm going to draw two grids, and I'll just do one curve up, and then I'll do one curve down here. And I'm just going to make up pretend points. So I'm just going to pretend here that my vertex is the point -3, -6. And then for this graph, I'll pretend that my vertex is -3, +8, just for pretend's sake. So let's do the range for both of these graphs. So here's the range for this graph. The range is always going to compare the y-coordinate to the vertex, the y-coordinate of the vertex. And it's going to be an inequality. It's either going to be less than or greater than. So here, when I'm looking at the first graph I've drawn, my y-coordinate for the vertex is -6. So I'm comparing y to -6 in this little learning example. And the graph is opening in an upward direction. So -6 would be a minimum value for this graph. So all other y values are going to be greater than or equal to -6 for this example. And then let's do the curve that turns down. So here's my vertex. It's a maximum at the top. So to identify the range for this graph, I'm going to compare y to +8. And you can see that +8 would be the maximum value for this graph. So all of the other y values are going to be less than or equal to +8. And that should complete the opening note set.